All right, well, good morning. And here we are at week, I don't know, 5 or something like that. And I'm sure you've all heard the news that we're going to be here for the remainder of the year. So, well, let's make the best of it. So let's start off with a Snapple fact. And it says here that almonds are members of the peach family. Did not know that. So, hopefully things went well with the previous lesson. I think they did. They did go pretty well, I think. So I have some more complicated linear programming problems today, just 3 of them for you today. And I'd like to think this will be our last linear programming lesson, I hope. So let's get started. So the approach to these problems is the same as the other problems, only these are just a little more complicated. Things are not quite as obvious, but again, not too difficult. So as always, we need to figure out what it is that we are trying to maximize, how many of x and how many y. We need to figure out what those 2 things are. Generally, there's 2 of them, because we're going to work with a linear system of equations. And, crap, that reminds me, I didn't make the graphs, but we'll manage it. And the other thing we need to do is find the limiting factors and include those as well. So the best way to find out the things that you're trying to maximize, the number of items that you're looking for, is to go right to the end of the problem and pretty much read the last sentence and find out what's being asked. So here it says, if Bob makes $390 in profit on a small shed and $520 on a large shed, how many of each type of building should Bob build to maximize his profit? So the question is, how many of each type? So that's what we got going on right here. These are the things we're trying to figure out. We want to figure out how many small and how many large sheds that Bob should build. And we'll cleverly call it X and cleverly call that one Y. Now, as we already know, also, over here in the left column goes the limitations. So what is it that's going to prevent Bob from building a bajillion small sheds and large sheds? So let's read through the problem and see if we can find out what's going to limit that. And we're going to look for words like at most or at least or whatever, things like that. Okay, so Bob, as in Bob the builder, Bob builds tool sheds. He uses 10 sheets of drywall and 15 2x4s for a small shed, and 15 sheets of drywall and 45 2x4s for a large shed. All right, so already we can see how many are required for each, so that's what's going to go over here. He has available 60 sheets of drywall and 135 2x4s. Actually, that's what goes over here. If Bob makes $390 in profit on a small shed, 520, yeah, we'll use that stuff later. Okay, so he uses 10 sheets of drywall and 15 2x4s for a small shed. So we can already see that the limiting factors are his materials. So we got drywall and we got 2x4s. And that's all we have as limiting factors, because that's all he needs in order to build his sheds here. So it says here, he uses 10 sheets of drywall and 15 2x4s for a small shed. So 10 sheets of drywall. So that's going to be 10 for every small shed. 1 shed, 10 sheets of drywall. 2 sheds, 20 sheets of drywall, and so on. So that's the way we do 10 times x. And it also says he needs 15 2x4s. So we got 15 2x4s for every small shed. 2 small sheds, 30 2x4s, and so on. So we go on to the large sheds. He needs 15 drywall and 45 2x4s for a large shed. So we need 15 of these, and what did I say? 45 of the 2x4s. And, right, okay. So he has available 60 sheets of drywall. So 60 sheets of drywall. So that means he can't use any more than that. So he can use less than 60, but not more than 60. He could use up to 60. And 135 2x4s. So the last 3 equal to 135. And Yeah. So here are the inequalities that we have that we're going to graph. So we're going to have 10x plus 15y is less than or equal to 60. And we're going to have 15x plus 45y is less than or equal to 135. And, yeah, so we'll solve those up, and we'll graph those. And then we need to figure out the ordered pairs. And so I'm actually going to graph those in just a moment. Actually, I'll just graph them right now. Should have done this ahead of time, but that's okay. You all have plenty of time. I'll just go to Desmos and graph these quickly. Desmos. In fact, you guys can graph them right now as well. So 10x plus 15y is less than. Actually, I'm going to turn that around. Remember, in Desmos, we want to turn that around, so it's going to be greater than 60. And we're going to have 15x plus 45y is greater than 135. Okay, so let me show you what that looks like here. Hopefully we can get to the important part of this. Nope, that's not a touch screen. Okay, so here's the important part of this. And so we can see that we have a region right here that looks like this. And you're thinking, okay, well, that's just a big open region. Remember, we flipped the inequalities around. But we need to remember also that, that we have to make some small sheds and some large sheds. So this region over here would be filled in because we're not going to make no or negative small and large sheds. And we're not going to make no or negative small sheds, so we're going to fill that in. So our shape is really going to be this shape right here. This weird four-sided shape right here. And so the ordered pairs for that are obviously 0, 0. That's one of the ordered pairs. But of course, that's not going to be a very useful pair for us. 0, 3, so we got 0, 0. 0, 3, that's another ordered pair. And we got 3, 2. And lastly, we have 6, 0. Okay, so those are the ordered pairs we have. And we need to figure out what's going to be our profit function, or our maximizing function. So it says, Bob makes $390 in profit on a small shed, $520 on a large shed. So $390 on a small shed. So we write right here, profit equals $390 on a small shed and $520 on a large shed. So you just take each of these ordered pairs and plug them right into here, and we figure out which one of these gets us the largest one. And I'm sure that we can all figure that out. We can just plug the numbers in and we will be done with that. So I want to save some time, jump over to the next problem. Okay, so same kind of situation as before. We want to set up a little table here, and the most important things to figure out are, what is it that we are making or doing or buying or whatever, and that goes along the top, and then along the side goes the limiting factors. And again, to find the stuff that goes on the top, pretty much read the last question or the final sentence where the question is and find out what we're trying to find out here. So it says, how many pairs of earrings and necklaces should Lisa make each week in order to maximize her profit? So we have earrings and we have necklaces. So ears and necks. It's a little weird. That's okay. Ears and necks. Okay, so what prevents Lisa from making as many ears and necks as she wants to make? So let's find out. Lisa has an online jewelry shop where she sells earrings and necklaces. She sells earrings for $30 and necklaces for $40. This is going to be the stuff you're going to use at the very end to figure out her profit, and you know, it's going to be this equation down here at the end. We don't need this yet, but we do need this. It takes 30 minutes to make a pair of earrings and 1 hour to make a necklace. And since Lisa is a math tutor, she only has 10 hours a week to make jewelry. So one of the limiting factors is how much time each week she has. So time is a limiting factor. And it says here that she can only work for 10 hours at most. Okay. And while we're doing this, let's sort out the time thing here. So it says here, it takes 30 minutes to make a pair of earrings and 1 hour to make a necklace. So we're going to try to keep these. So notice we have minutes here and where's it, hours here. I want to make sure these units are the same. So we're going to say half an hour and a full hour. So we're going to have 0.5x for earrings and 1 full y for necklaces. So time is a limiting factor. And what else is a limiting factor here? In addition, she only has enough materials to make 15 total jewelry items per week. Okay, so materials, materials. And she can only make 15 jewelry items. So at most 15. So that means the number of earrings and the number of necklaces have to total 15 or less. So these are our two inequalities that we're going to use to find our region that we are interested in. So I'm going to graph those up quickly on Desmos. And by the way, it's going to make the same shape as the previous one. So we got 0.5x plus y is, I'm going to again flip the sign around, make it greater than 10. And I'm going to change the other equation, or the other inequality, to x plus y is greater than 15. Move that down a little bit so you can see it. Hopefully it'll all fit on the screen there. Okay, and so here we are in that same shape as before. So I'm going to try to move the camera here a little bit so you can see all of it. So there's the whole shape over there. It's the same shape as we just saw earlier. Actually, if I was a smart man, I would just make this smaller here. There we go, hopefully. And move it over a little bit. Okay, there we go. So it's the same shape as it was before, and we can see that we're going to have 0, 0. Again, we're not going to have any negative pieces of jewelry over here or over here. So we're going to have 0, 0, but of course that's not going to help us because, you know, she needs to make some jewelry in order to make some money. And then we got 0, 10, and it looks like we got probably about 15 right there, and this looks like 10 something. So we'll get our order pairs. So we have 0, 10, and we have 10, 10, 5, and we have right here 15, 0. So 10, 5, 15, 0. So we have 10, 5, 15, 0. I think it was 0, 10, and of course 0, 0. Which again, of course, isn't going to help us at all. All right, so now we have to go back to our equation right over here and create our profit equation. It says she makes a profit of $15 on each pair of earrings, 20 on each pair on each necklace. So that's going to be 15x, so profit equals 15x plus 20y. And again, in the interest of saving time, we would just plug these numbers right into here and figure out which one of them makes the greatest profit. In fact, I could probably do these. So 10 here, that's 150. So I'm sorry, so 10 into here, 15 times 10 is, so 15 times 10 plus 20 times 5. So that's 100, and 150 is 250. Plugging in 15 here, so 15 times 15 is 225, plus 0 is 225. 0 here, 10 there, 15 times 0, plus 20 times 10 makes 200, and 0, 0 makes 0. So it looks like she should make that. she should make 10 earrings and 5 necklaces. Okay, and then we got one more to do. So, last one. So it says here, well, we're going to make our little chart, as always. In fact, here's what I'm going to do. I'm going to pause right here, and actually you're going to pause. And you are going to do this problem on your own. So I'm going to pause the video in just a moment. So actually, I'm not going to pause the video. Again, you're going to pause the video. You do the problem, come on back, and then we'll do this all together. So take a moment to try it on your own. So hopefully you paused and you're back, and things are going to go perfectly. So let's find out. Where are we here? Going to the end of the problem here, it looks difficult to figure it out, so let's read the whole problem and see what the farmer is trying to do here. Farmer Bob. A farmer can plant up to 8 acres of land with wheat and barley. He can earn $5,000 for every acre he plants with wheat, $3,000 for every acre he plants with barley. His use of a necessary pesticide is limited by federal regulations to 10 gallons for his entire acreage. Wheat requires 2 gallons of pesticide for every acre planted. Just 1 gallon. What is the maximum profit he can make? Okay, so in order to figure out the maximum profit, clearly we need to know how many acres of wheat and how many acres of barley. So we have wheat and we have barley. We'll cleverly call those X and Y. And again, it doesn't matter. You could have switched them, and that's fine. And so what are the limiting factors? Well, it says here, his use of a necessary pesticide is limited by federal regulations to 10 gallons for his entire 8 acres. Okay, so let's actually deal with this whole 8 acres thing first, because that's the easy thing to deal with. So we know that we have acres. So that's going to be one of the things, and it says here that he has 8 of them. So he can't plant any more than 8 acres. So we're going to be less than or equal to 8. And it says he has a certain number of acres of wheat and a certain number of acres of barley. So we got X and Y. And the other thing that is restricting him from doing whatever he wants to do here with all of his planting is that he needs to use a pesticide. So, pesticide. And it says he must use 10 gallons of pesticide. So we got less than or equal to 10. It says wheat requires 2 gallons and barley requires 1 gallon. So we need 2 of those and 1 of those. So these are our 2 inequalities. So we graph those together. And we have x plus y is less than, well, so again, we're gonna flip that around and make it greater than 8. And then we have 2x, and that has to be greater than 10. And so again, we have our little figure right here, and we have our ordered pairs, which are, first one's right there, 0, 8, next one's over here, 2, 6, and the last one's over here at 5, 0. So 2, 6, 5, 0, 0, 8. 2, 6, 5, 0, 0, 8. And again, 0, 0. But of course, 0, 0 isn't going to help anybody because you got to plant some acres in order to make some profit. All right, so let's see about the profit bit. It says here that he can earn 5,000 for every acre he plants with wheat, 3,000 for barley. So wheat is x, so it's 5,000x plus 3,000y. That's our profit. And that's it, right? 5 and 3? Yep, good. Okay, so we just plug those in there. So 5,000 times 2 is going to be 10,000, just so I can write a little less here. 10,000 plus 6 times 3,000 is 18,000 for a total of 28,000. 5 and 0, so 5 times 5,000 is 25,000. plus nothing is 25,000. And 0, 8. So 3,000 times 8 is going to be 24,000. 24,000, and that's 24,000. And 0, 0, of course, is 0. So, in order to maximize his profit, Farmer Bob should plant 2 acres of wheat and 6 acres of barley. 2 acres wheat, 6 acres barley. Okay, so we're at about 20 minutes, 21 minutes, so hopefully that went well and you got that correct. And I'll see you again on Wednesday. And yeah, keep being safe. I'll see you guys.